Let's learn how to compute determinants of 2 by 2 matrices and 3 by 3 matrices. The determinant of a 2 by 2 matrix is easy to compute. If the matrix is A, B, C, D, then the determinant is AD minus BC, which is the product of the numbers in the main diagonal, A times D, minus the numbers in the anti-diagonal, B times C. For example, the determinant of 3, 7, 2, 5 will be 3 times 5 minus 7 times 2, which is 15 minus 14, and it's 1. Now, how do we compute the determinant of a 3 by 3 matrix? I'm going to show you two different methods to remember the formula for a determinant of a 3 by 3 matrix, and the first one is just multiplying diagonals like in the 2 by 2 case. So first, we're going to add up the products of the main diagonals, and there are three now. The first main diagonal is A times E times I, which is this term, plus. And now I'm going to imagine that this same matrix, I've replicated it below it, so that this diagonal starts with D times H, and the number that would be here would be the number C. So that's D times H times C, which is this triple product, plus, and then for this diagonal, it would continue with the numbers B and F here, so I'm going to multiply B times F times G for the third diagonal. And next, I'm going to subtract the product of the anti-diagonals. So the first anti-diagonal is C times E times G, which is this triple product, minus B times D times the number that would appear over here, which would be I. So B times D times I, subtract that triple quantity, and A times F times H is the last product of an anti-diagonal. So the determinant is calculated by this sum of triple products minus these sums of triple products. For example, this determinant would be 1 times 5 times 9, 4 times 8 times 3, 2 times 6 times 7 for the positive diagonals, and then minus 3 times 5 times 7, minus 6 times 8 times 1, minus 2 times 4 times 9. And these are all the triple products I have to compute, add it all up, and you get 0 in this case. The determinant is equal to 0. The second method I want to show you for a 3 by 3 matrix is what we call the expansion along a row. Here I'm expanding along the first row, and the first term will be A times the determinant of the numbers I get when I cancel out the first row and the first column. You see, I get 4 numbers left, and that's the determinant I'm calculating here. The second term will be minus, don't forget that minus B times, again, the determinant I get when now I cancel the first row and the second column. So you see I get D, F, G, and I left out, and that is the determinant I compute here in this second term. And the last term will be plus C times the determinant that I get when I cancel out the first row and third column, which is the determinant of D, E, G, H. For example, if I compute that determinant using this second method with the expansion along the first row, what I get is this formula where these coefficients 1, 2, and 3 are the coefficients from the first row with alternating signs, and the determinants are those that I get when I cancel the appropriate first row and then the column. So for example, this one is what I get when I cancel out the first row and the first column, and I get that determinant, which, as we learned before, that determinant is 5 times 9 minus 6 times 8. And if you do everything out, you get 0 like before.